Welcome back, ladies and gentlemen. Chapter 12, Lesson 6. I will make input-output tables for linear equations. These will be equations with two variables. So that's the big deal for today. Go ahead and pause your video. Come on back when you're ready. And so here we go. Now, actually, this might look somewhat familiar to you. After all, we've been doing bell work of visual representations for quite a while. The only difference here is we have no pictures, but that's okay. Our goal is to find solutions. Notice I'm going to give it plural right now. Solutions to these equations today. Now remember that a solution is a number or numbers that makes a statement true. Therefore, what you can do is, that could be a problem. Use the equation one by one. The equation says y equals -3 times some x amount. So let's start with 0 and then do +1 and -1. Now for me, I always start with 0. I don't know why. Maybe it just it seems easy to me. So -3 times 0 is 0. There is nothing in addition to add or subtract. And therefore, when x is 0, y must be 0. That's the only way to make a true statement. If you put in 0 for x and 4 for y, it's going to be false. If you put in 0 for x and -3.5 for y, it's going to be false. There's no other combination when x is 0 that would make a true statement other than y must be 0. All right, let's try a different amount now. Let's try +1. So when x is +1, what must y equal? Y equals -3 times 1, so y equals -3. Again, if I were to substitute in 1 and any other amount, -2, -21, +54, even 54 trillion, and any number in between, it's going to be a false statement. The only way this could be a true statement when x is 1 is if y were -3. Nevertheless, we've already come up with at least two solutions to this. X could be 0 and y could be 0. X could be 1 and y could be -3. Remember that a solution is a number or numbers that makes a statement true. Let's wrap up with another one. When x is -1, what must y be to make a true statement? Well, of course, the opposite of all those positives would be, the opposite of all those negatives would be positive. So when x is -1, y must be -3. To say it one more time, if you put in any other number, even 2.98, it's going to be false. The only way this could be a true statement, if x is -1, y must be 3, and then it's true. And yet already, folks, we have counted 1, 2, 3 different solutions, ordered pairs, that would make this equation true. But just because our table stops doesn't mean that the number of solutions would stop. In fact, we could try 2, we could try 2.5, we could try 2.5 million, we could try -3 and 57 hundredths. We could try -3.57 trillion, and any fraction, decimal part, piece, portion in between. The fact of the matter is that this equation has infinitely many solutions. You come up with a number, I'll add a little bit and make up another one. There is no limit to this. And if this leads us into a few days from now, think about what this would look like. There's a point 0, 0 that's a solution. There's a point -1, +1, -3 that's a solution. There's a point -1, +3, there's a solution. And to be frank, there are billions and billions and billions and billions and billions and billions. Okay, you get it. Enough, Mr. Count. Hey, look what that looks like. Instead of drawing billions of points, we are going to draw a line that displays all the infinitely many points, x and y ordered pairs, that would make this equation true. So ladies and gents, welcome to the world of linear equations. That's why they're called linear equations, because all the solutions meet to form a line. But I'm getting you a little ahead. For today, we're really just focused on x and y input-output tables. Let's go ahead and do the same thing here, where I'm going to write in, you know what, I'm going to start with 0. That's me. I always like to start with 0. 3 times 0 is 0. 0 plus 1 is 1. So when x is 0, y must be 1. That would make a true statement. I don't know why I wrote -1 in, so let's just go ahead and do that one. 3 times -1, of course, is -3. Now go up or increase 1, and you're at -2. So when x is -1, the only output value, we call that input because we put it in, we insert it. The only output value that would work to make a true statement would be if y were -2. All right, let's go ahead and get rid of that. Let's try another one, naturally. You'll often notice that I start with 0 and use at least one positive and one negative. That's a suggestion, but it really is a good idea. So 3 times 1, of course, makes 3. Now increase 1 from there, and the y value must be 4. In other words, if x is 1, then y must be 4 to make a true statement. So the ordered pair 1, 4 is a solution, 0, 1 is a solution, -1, -2 is a solution, and shucks, there are infinitely many solutions that are part of this equation. If you're really curious, this line would look like the billions and billions and billions and billions of different solutions would look something like that. But that's getting you ahead again. Let's do a few more, shall we? So I always start with 0. 2 times some input value, take away 2. Well, let's input 0. 2 times 0 is 0, minus 2 is -2. So when x is 0, y must be -2. Now let me go ahead and infinitely clone this sucker. And let's go to +1. 2 times 1 is 2. 2 minus 2 is 0. Oh, that's interesting. So when you input 1, the only output value that would make a true statement is 0. All right, let's go ahead to -1 now. Now 2 times -1 is -2. I have to slow myself down a little here. Speaking of down, go down further, and y must be -4. Therefore, when x is -1, the only output value that would come out of this equation, y must be -4. On Word, this one's interesting. It says y take a third of whatever input value you want and then decrease or go down 4. And of course, ladies and gents, if you wish, you can change that little disappearing ink here into adding the opposite. Now I'm going to go ahead, infinite clone that fella, but you know me, I'm going to start with 0. So a third of 0 is a 0. Now go down 4 and you're at -4. So when you input 0, your output is -4. Now some of you might be wondering, why didn't you just do 1? We've always done 1. Well, the short answer is we can. But follow me for this. 1/3 of 3 is 1. Now go down 4 and you're at -3. 1/3 of 1 is a third. Now go down 4. What are you at? Now you guys probably can handle it. When you're starting at 1/3 and you go down 4, you're at -3 and 2/3. Could I introduce the point 1, -3 and 2/3? Absolutely. But now ask yourself, which is quicker, more efficient, to use that E from the PRIDE acronym? And I think you can realize that it would be more efficient to take 1/3 of 3. So that, ladies and gents, is why we steered our input values to -3 and 0 and +3. Check this out. 1/3 of -3 is -1. Go down 4 and you're at -5. So could we have used -1? Sure. Could we have used -2? Sure. Could we have used -2.5? Well, yeah, we can find out what a third of anything is, but steer your values wisely. Steer your input values wisely when you have a fractional coefficient. I'm going to leave that seed with you. What does Mr. Cowan mean? What numbers would we use if there's a fraction? Well, let's go on and do another one, shall we? This says y is equal to -3/4 of whatever input value you want and go down 2. Now I wonder if you could look at those input values that I chose and why we would do those. But for now, let's start at 0. You know, Mr. Cowan, we're going to start at 0. Just seems to be one of the easiest ones here. So what is 3/4 of 0? 0. What's the opposite of 0? And there is no opposite, but go down 2, and your output value would be -2. So when you input 0, the only output that would work and make a true statement is -2. Now let's do it again, and look at there. Mr. Cowan is suggesting 4. Why? Because 1/4 of 4 is 1. Take 3 of those, it's 3. Take the opposite, it's negative. In other words, and you could always put a 1 underneath if you wish, but you end up with 12/4, which is 3, and the opposite of that is negative. By the way, go down 2. Some of you like to change that to adding the opposite. A little easier to see that when the input is 4, the output must be, you guessed it, -5. Let's try this one. But instead of doing -1 or -2 or even -3, let's go to -4. ¿Por qué? Why would we do that? Because the 4's cancel out, and we end up with the opposite of a negative or a positive 3. Now, go down 2, add the opposite, I don't care. And so, not that I'm asking you to do this, but if you were to graph this out, here's 0, -2, here's -4, +1, here's +4, -5, and you start to see the billions and billions of points. Oh, and by the way, which one? Well, never mind. So that's why eventually we'll learn to draw a line to stand for all those billions and trillions of solutions. All right, one final challenge. Before we get to assignment 6, which is right here, what if you're asked to go the other direction? What if instead of giving you the equation and having you find the table, now we turn the table, so to speak, give you the table of values and find the equation. So I'm going to do one of those, or if you wish, you can pause, try to figure it out on your own. The first thing I'm going to do is I'm going to look, is there a constant rate of change? If so, what is it? This y value goes up 4 as the x value goes up 1. This y value goes up 4 as the x value goes up 1. This y value goes up. Aha! There is a constant rate of change. That constant rate of change, don't forget, rise versus run. The change in the y value versus the change in the x value. So our constant rate of change here is 4 to 1. Now, could you write 4 to 1? Yes, you could. I'm just going to write 4. But before you get too excited, ladies and gents, I'm going to go ahead and erase this, and I'm going to say, is that good enough? Is that good enough? If I put in 4 times 1, that equals 4. Oh, that works. If I put in 4 times 2, that equals 8. Oh, sweet. All right. 4 times 3 is 12. Let me just check the last one for kicks. Oh! So honestly, little disappearing ink here, you don't have to put in the +0. But then why would Mr. Cowan leave that blank there? It's almost like we know sooner or later we're going to be off by a certain amount. So if you would be off, ask yourself, how far are you off? And are you too high? Then go ahead and subtract. Are you too low? Then go ahead and add. One final thing I would encourage you is to look for the starting value of the y-intercept, the 0 point. In other words, instead of going up 4 repeatedly, why don't you go the other way? Now in this case, it ends up being a lovely 0, but I'm not so sure that's going to be the case for every time. All right, ladies and gents, that's what I got for you. Feel free to pause, rewind, rewatch if you need. Homework for tonight, page 347, numbers 8 through 24. Have at it, let's grow. I'll see you soon.